In this video, we're going to talk about polynomials. All right, this is one of the types of functions that we are going to study in this course this semester. And so let's get some information about working with polynomial expressions. And so polynomials in one variable are algebraic expressions of the form a sub n to the x times x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2, all the way down until we get to plus a sub 2 x squared plus a sub 1 times x plus a sub 0, right? And so basically we have a bunch of terms, right? Each of these individual pieces that are separated by a plus sign are called terms, and all of the terms are of this form. It's some number multiplied by a variable raised to an exponent. Those numbers, a sub n minus 1, so on and so forth, are called your coefficients. A sub n is a special coefficient, which we call the leading coefficient. A sub 0 is a special coefficient. That's this one down here. It's called your constant term. And n is the degree of your polynomial. One of the things about this n is that it is the largest one because all of my other exponents are n minus 1, n minus 2, all the way down until we get to n equals 1, n equals 2, n equals 1, and then in all actuality, this will be n to the equals 0 for the constant term here. All right, and so n is an n is an element of the whole numbers. It's a number, one of your counting numbers plus 0. So 0, n equals 1 here, 2, 3, 4, all the way up to the highest power we have in that polynomial. Now, normally polynomials look something like this: 3x squared minus 4x plus 4, right? That is a polynomial function. Notice your highest power, this is of degree 2. It has 3 terms. Our constant term is 4. Our leading coefficient is 3. And so what we're going to do in this section is learn how to work with these types of algebraic expressions. Some special definitions: polynomials with one term are called monomials. Polynomials with 2 terms are called binomials. Those with 3 terms are called trinomials, right? And there are other names for these polynomials, but these are some that may come up ever so often. And so now you're aware of those terms. And so we're going to look at this first example where we give the degree of the polynomial, its leading coefficient, constant term, and we're going to state what type of polynomial it is. It's 3x cubed minus x, right? So normally our general convention is to write our polynomials in this form where the highest, the term with the highest degree, our exponent, is first, followed by the term with the next highest degree, so on and so forth, right? And so this one is written in the way that we always write polynomials. And so when it's written that way, if we want to know the degree of the polynomial, look at the first term. Our first term is 3x cubed. The degree here is 3. All right, the leading coefficient is the coefficient on the leading term. That is also 3 here. My constant term, notice I don't have a constant term here, or it's understood to be 0, right? And so when you don't see a constant term and it only has variable terms, our constant term is 0. And my type of polynomial, we're going to use one of these 3 words here. This will be considered a binomial. I'm going to write some other stuff, right? A polynomial where n equals 1, where the highest degree equals 1, equals 2, n equals 3. They have special names too. All right, this one is constant, right? If n equals 0, my polynomial is a constant polynomial. It would be in this case right here. So any number is actually considered a polynomial, all right? They're not very interesting to work with, and so we don't usually consider them polynomials, but that is true. It is a polynomial. N equals 1, we call those linear polynomials. And so an example of a linear polynomial is something like x minus 7. The highest degree is 1, right? 7 is a linear constant polynomial, for instance. The highest power is 2. We call that quadratic. I guess you can't see all of that. I am so sorry. So my linear polynomial I wrote as an example x minus 7. My quadratic polynomial, the degree is 2, so something like x squared plus 3x minus 4 would be considered a quadratic polynomial. And when n equals 3, your degree of your polynomial is 3, you have a cubic polynomial, right? So something like x cubed minus 7x plus 7x minus 1. That is, and of course I missed my squared here. That's an example of a cubic polynomial. So sometimes we like to use these words to describe polynomials. And so this one is binomial since it has two terms. You can also call this cubic based off of the highest degree. So this name is based off of the degree. This name is based off of the number of terms, right? There we go. What we really want to get to is how to add, subtract, multiply, and divide polynomials. That's all we want to talk about in this video, right? And so whenever we're adding and subtracting polynomials, it is as simple as combining like terms. And like terms are terms that have the same degree, all right? So if I see two terms that have the same degree, like 3x squared minus 8x squared, then I can combine those two together to give me a negative 5x squared, all right? And so that's combining like terms, right? The squares are the same. You just do the operation with the numbers. When you're multiplying polynomials, you want to multiply the coefficients and then use your rules of exponents, right? And so if I had something like 3x squared times 8x squared, well, what I'm going to do is the order in which I multiply doesn't matter. So I could rewrite that as 3 times 8 times x squared, although we don't have to do that. And then I can multiply the 3 and the 8, that's 24, and the x squared and the x squared, that's a product rule, right? So I add my exponents when my bases are the same. So I get 24x to the 4th, right? That's what we do when we multiply polynomials, all right? Multiply the terms, the coefficients, and the rules of exponents. Use your rules of exponents, all right? If the polynomials have more than one term, we're going to use the distributive property. So let's look at these three examples here. In part A, we have an example where we are subtracting two polynomials. One of the things that I like to do when we subtract, there's many ways that you can write these. You can stack them on top of each other. It really doesn't matter to me what you do. I'm just going to write them this way. What I like to do when I have a subtraction is I like to distribute my negative before I combine my like terms, just so I can remember, right? So if I distribute my negative to the 3x, that'll be a minus 3x squared. To the next term, that'll be a plus 6x. To the next term, and minus 9. Now I go and find my like terms. 3x squared and x squared. Our x squared minus 3x squared is a negative 2x squared, right? And then the like terms are here with the negative 2x and the 6x. Those combine to 4x. And 4 minus 9 is a minus 5. Let's go to part B here. We have a monomial multiplied by a trinomial that's quadratic. Let's just use our distributive property, right? So that'll be a negative 2m cubed plus 6m squared minus 18m. All right, you just multiply the coefficients and add the exponents together, right? And last but not least, we have binomial multiplied by a trinomial here, a linear binomial multiplied by a quadratic trinomial. And so what we're going to do here is we're going to take each term in this first polynomial and multiply it by the second polynomial. So I'm going to take that 2x and I'm going to multiply it by the 4x squared plus 2x plus 1. And then I take that negative 1, I'm going to write it as a subtract 1, and multiply that by all of the terms in the second polynomial. When I do that, I use my distributive property here. So I get an 8x cubed, use my distributive here, plus 4x squared, use my distributive property here, plus 2x. I'm going to distribute here. That'll be a minus 4x squared, minus 2x, minus 1. All right, we cancel our, combine our like terms. Oh, with the 4x squared and negative 4x squared, they cancel. And the 2x minus 2x, they're 0, they cancel. And so we're left with 8x cubed minus 1. And this type of product of a polynomial in this form right here, which ends up being of this form right here, it's a special case we'll see when we get to factoring. All right. So that's adding, subtracting, multiplying, right? Let's get to dividing. Dividing polynomials is probably the most difficult thing, right? Now, it is pretty simple when your denominator has one term. All right, so like for instance, if I had 3x squared plus 6x minus 9 over a 3x, for instance, right? What we're going to do is we're going to divide the coefficients and we're going to use our rules of exponents. I want to be clear, right? You can divide each term separately. Because your denominator only has one single term separated by a multiplication. And so what we can do here is I can write that as 3x squared over 3x plus 6x over 3x minus 9 over 3x, right? And that's going to give me my solution, right? When you simplify, remember your rules of exponents here, you subtract your exponents when your bases are the same, or you can cancel them out here, and that 3 will cancel with that 9, but that x has to stay in the denominator, all right? That's what we do when we have a polynomial with one term. Let's look at another example of that and where I work through all of that. I'm going to skip to example 4. Here I have negative 24y to the 12th divided by 8y cubed, right? Well, for me to do this division, well, 8 goes into 24, negative 24, negative 3 times. And if I subtract my exponents, 12 minus 3 is 9. So I get 3y to the 9. If I go back up to that example, I know I'm going all over the place here, but what I would do here is 3 divided by 3 is 1. X goes into x squared, x times. So I have an x for that first term. 3 and a 6 is 2. The x is canceled. And then I get a 3 over x there because 3 goes into 9 3 times, or I can cancel out a 3 here. So there's a 3 in my numerator, and that x doesn't cancel in my denominator. So I get 3 over x. That is that division when I have one term, right? So this is one term. When the denominator has more than one term, we have to use long division to do the division, all right? And so let's look at a review of long division with numbers, right? It says use long division to divide 7 into 1,744. All right, now I'm going to do something that's a little bit extra here. I know you guys know how to divide, or if you don't, we're going to get a good review, but I'm going to put a little bit extra, and I'm going to be very intentional here because when you divide polynomials, there are a lot of steps that you can get confused about, right? The first thing we try to do is we try to see what whole number amount, at most how many times does 7 go into a digit, right? And so my first digit here is 1. How many whole number times does 7 go into 1? Well, 7 doesn't go into 1, and so we go to the next digit and consider how many times does 7 go into 17. Now, I'm going to come off to the side, and I'm going to do some scratch work, right? I'm going to do 17 over 7, right? If I were to think about how many times at most that goes into it, it would be 2 at most, and I'll have a remainder of 3, right? Because 2 times 7 is 14, right? Now, what we're interested in when we do this long division with just numbers is just that 2 there. So what I'm going to do is I'm going to put 2 over there on the top of my division. And then what I would have to do is I would have to multiply the 7 times the 2, which is 14. And I'm going to stack that right under that 17, right? So what we did first was we did a division, and then we did a multiplication. And then what we're going to do now is we're going to subtract. When I subtract, I'm going to get a remainder of 3, which is that same remainder that I had over here. Okay, so we divide, multiply, and then we subtract it. And that was in the actual division chart. Now I'm going to bring down my next digit, and I'm going to start this process over again, right? I start with a division. I see how many times the 7, at most, the 7 go into 34. Well, I think about it. Well, 7 times 4 is 28. If I do 7 times 5, that's 35. That's too big. So 7 times 4, and I'm just going to worry about the whole number now, okay? I'm not going to think about the mixed number, right? So 7 goes into 34 at most 4 times. So I'm going to put that 4 there. That's my division. Then I'm going to do a multiplication. I'm going to do 7 times 4. That's 28. So I'm going to put the 28 here. I'm going to do a subtraction. I get a remainder of 6. And that was coming from my subtraction. So I have a repeated division, multiplication, subtraction. Division, multiplication, subtraction. Bring down the next term, and we're going to do the exact same thing. I'm going to have a division. 64 into, how many times does 7 go into 64? That's 9 at most. So I put my 9 in my answer. Then I do my multiplication. Then we subtract. We get a remainder of 1, right? This number is called your quotient. It's kind of your result when you do your long division. This is called your dividend. This is called your divisor, what you're dividing by. And this is called your remainder. And so if I take 1744 and divide it by 7, I get 249 plus 1 over 7. All right. That means I have my dividend divided by my divisor equals my quotient plus my remainder over my divisor. Okay. That is what we get when we do long division. All right. Now, I'm going to be a little extra right now, right? What if I multiplied both sides of this equation here? If I multiply both sides by 7, right? So if I multiply this side by 7 and I multiply this side by 7, right? Well, if I do that, the 7s are going to cancel over here, and I'm going to get 1744. Okay? And if I multiply 7 over here, since this is 2 terms, by the way, this is a mixed number, so usually we'll write this as 249 and 1/7 without the plus sign. The mixed number always has that plus sign there, and I'm being specific here because this is the division algorithm. But if I multiply this by 7, what I'm going to do is I'm going to write it as 249 times 7, right? And when I distribute it to the 1/7, I'm just going to get that 1 there. Notice I multiply by this divisor here, all right? And when I multiply by this divisor, I was left with just the dividend, which is that dividend. That's dividend, all right? I know it looks like squiggle. All right, that's my dividend. So I multiply both sides by 7. I got my dividend, which is this 1744. You can also think of coming over here and multiplying both sides by your divisor. I want to see what these words are. All right. So I get my dividend equals my quotient. I'm going to abbreviate that with Q times the 7. The 7 is my divisor. Plus the 1. The 1 is my remainder. All right. This is our division algorithm. It's basically saying that you can rewrite any number, which is your dividend, as a product of 2 numbers plus a remainder. You can write your any number as the product of 2 numbers, they're going to be called your quotient and your divisor, plus a remainder. That's the division algorithm, and that's exactly what we're going to use to divide polynomials when there's more than one term. All right? So now we're going to write it in polynomial and function notation. I'm going to use P of x for dividend, and I'm going to reserve the D for divisor. All right? And we're using P because it's the polynomial that we're interested in dividing into for your dividend. So P is your dividend, D is your divisor, Q is your quotient, R is your remainder. And basically, we have our dividend for any two polynomials, P of x and D of x, where D of x does not equal 0. Remember, your D of x is your divisor. We don't want to divide by 0, so that's why we have this statement here. There exist unique polynomials Q of x and R of x such that we can rewrite P of x as Q of x times D of x plus R of x. And again, this in words, quotient times divisor plus remainder. All right. Now, at times we want to present our solution to make it look this way. So we'll write it as the quotient plus the remainder over the divisor. But the division algorithm is written this way. All right, but 9 times out of 10, when you submit your homework, they're going to ask you for the quotient and the remainder, or they'll have you write your solution in this manner here, where you take your quotient plus your remainder divided by your divisor. Let's look at an example. Have x cubed plus 3x squared minus 3x plus 4 over x plus 4. What I'm going to do is I'm going to change this slightly just so we can talk about something. I'm going to remove this term here. All right, let's say we were getting rid of that term. And so when we set up our long division, our denominator is our divisor, and the thing that we're dividing into is our dividend. What we have to make sure is that this is written in the general convention in how we write polynomials. That means it needs to be the highest exponent first, the term with the next highest exponent second, so on and so forth. The reason why I wanted to get rid of that minus 3x is because when you're missing a power of x or one of the terms in your polynomial, once I took that out, I don't have a linear term or a term with x to the first power. What you need to do is you need to replace that with 0 or 0 times that variable, that power of x that you're missing, right? And so that is why I am doing this here. And this for logistical reasons, because if you don't do that, you're going to get very confused, and I don't want you guys to get confused, all right? So what we're going to do is we're going to go through this repeated process of doing a division, a multiplication, and a subtraction, all right? And it's very similar. However, the division and the multiplication are slightly different when we do long division. Let's take a look. I'm going to start with my division, the D part. All right, I take my first term, which is x cubed, and I divide it only by the first term of the polynomial in my divisor. All right, so I divide it by x only, right? X cubed divided by x is x squared. That goes into my quotient. So that's my division. And then my multiplication actually takes that x squared that I just wrote up there and it multiplies it by both terms or every term in that divisor, right? So the division step only uses the first term in our divisor, but the multiplication step uses both terms, right? That's the difference between when we do numbers versus when we do polynomials, right? Notice when I distribute this, I get x cubed. And when I distribute that to there, I get plus 4x squared. All right, let's do a subtraction next, right? So subtraction is next. I'm going to do it in the here. Notice this is an x cubed, a minus an x cubed. That's 0. That should always be a 0 there. If you don't get a 0, you didn't do something right. All right, these two should always cancel. Now I'm going to do a 3x squared. This is a minus a 4x squared, so I get a negative x squared. I'm going to bring down my next term. And notice here, I'm only bringing down one term because I need two terms here for my next division. And the reason I know I need two terms here is because I have two terms in my divisor. All right, let's start the process over again. I'm going to start with division. I take the division here. I divide it into the first term of my divisor. I get negative x, so I'm going to put that minus x there. Then I do my multiplication, and when I do my multiplication, I take that negative x and I multiply it by both terms in my divisor, all right? So I get a negative x squared minus a 4x, and then we move on to subtraction, folks. I go to subtract. All right, that's a negative x squared minus a negative. That changes that to a positive. That cancels. A 0x squared minus a negative 4x, all right, that becomes a plus positive 4x. And I have one additional term to bring down here. So I'm going to come over here and I'm going to do a division. I take 4x and divide it by x. I get 4. So I'll write my 4 here. Multiply the 4 times both terms in my divisor, or my entire divisor. I get 4x plus 16. I do a subtraction here. 4x. All right, and I always put this in parentheses to remind myself that I got to distribute that to both of these terms, right? Those cancel, and I get a negative 12, right? And so I can write my solution. I can say that this equals x squared minus x plus 4 plus a negative 12 over my divisor, which is x plus 4. All right, that's my quotient, that's my Q, plus my remainder over my divisor. All right, and so the division algorithm is written this way. Again, if you divided both sides by d of x, which is your divisor. All right, I should have put q of x, but that would be your remainder divided by your divisor. All right, so that is long division. It can get complicated, but as long as you follow these steps, you should be fine here. And so that concludes this video.